Now we're going to take a look at story problems with the law of cosines. It still uses our bearings, and we still want to create a picture. So two airplanes leave an airport at the same time on different runways. One flies on a bearing of north 66 degrees west at 325 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? So I'm going to call this A for airport. Two planes leave an airport at the same time. So our first airplane is coming from the north, 66 degrees west. So this right here is 66 degrees west. Okay. The other airplane flies on a bearing of south. So here's the south one, 26 degrees to the west. So like there. Okay. And then we want to know how far apart they are after 2 hours. Okay. So this is, now we need to find more pieces of information. Now on this one, we can tell what this amount is by doing 90 minus our 66, which is 24. And I can tell what this part is by doing 90 minus the 26, which gives us 64. So that means that this full angle is the 24 plus the 64, which gives us 88. Okay. Now we've got this other piece of information that says this plane is flying 325 miles per hour. This plane is flying 300 miles per hour, and we're looking at how far apart they will be after 2 hours. So we have to do a little bit of math. So hopefully you remember that distance is rate times time. So in this case, for our first airplane, the distance that is going, the rate is 325 miles per hour, and the time is 2 hours. Right? So if we do 325 times by 2, that gives us 650. So that means that the first airplane, which was this one, has gone 650 miles after 2 hours. If we look at the second plane, we still do the distance equals rate times time. So our distance is, it's going 300 miles per hour, and it's gone for 2 hours. So then that just gives us 600. So this plane has gone 600 miles. Okay. Now, if it helps, you can remake your triangle. Say this is 88. It may not be precisely like that, so it may be like more like that. Okay. So this is 600 and this is 650 so that you can see easier. Now on this one, I have no information about these angles and I don't know this side that's across from the angle that I know. So I cannot use law of sines. I also have no other way of finding these angle measurements. Okay. So what I'm going to do is use the law of cosines. So it's saying how far apart will the airplanes be after 2 hours. So that means we're finding this distance, right? Because this was the airport, so this is side A. So if we're finding side A, that means I want A squared. Then I need the two other letters that aren't there. So the two sides that aren't this one, so the 650 and the 600. So 650 squared plus 600 squared minus 2 times those two sides that we just multiplied, or squared rather, and times by the cosine of the angle opposite this side. So this one is 88. Okay. We're solving for A, so I can put this entire thing in the calculator. Okay, so you can see okay, so if I go to calculator, you can do the Desmos scientific calculator. So you're going to do 650 squared plus, or the graphing one, either one is fine. But this one has the second answer button. So 650 squared, 600 squared, minus 2 times 650 times by 600. Oops. Close my parentheses, times by the cosine. And then I look up on my calculator to switch calculators. I want to check. Remember, this one, whichever one is visible, is the one that it's in. So cosine of 88 degrees. I close my parentheses. So that gives us that really large number. So 755,278. So A squared equals 755,288. Maybe if I remembered correctly. So we don't want that. We want the square root of that. Again, we don't have negative distances yet 278 is what it was. So I'm going to do the square root and then use answer, which is below number 3. So we get 869.068. 869.068 equals A is 755,278. It was close. Okay. So then this gives us our value of how far apart. So they're just shy of 870 miles apart. Now this one gives us a picture. So we have find the distance across the lake from A to C to the nearest yard using the measurements shown in the figure. Okay, so here's our lake. We're finding the distance across the lake. So we know this is 140 yards and this is 80 yards and this angle in between them is 80 degrees. Okay? So notice I don't have any interior angles for these two. I don't have this side length. So I just need to, or I don't have a side and an angle across from each other, which is what I was trying to verbalize. So I cannot use the law of sines. So that means I have to use the law of cosines. So if we're trying to find the distance across the lake, that's this one. So we're trying to find side B. And that's what we're looking for. So if we're doing B, that means I do B squared equals, and then the other two sides squared that aren't that one, so 140 yards squared and 160 yards squared, and then minus 2 times those two sides, so 140 times 160 times by the cosine of the angle, which in this case is 80 degrees. Right? So I can put that in the calculator. So if we go to the calculator, we're going to do 140 squared. Now you can, if you would want, I could just show you this. You could do the square root of 140 squared plus 160 squared minus 2 times 140 times by 160 times by the cosine of 80. I make sure my calculator's in degrees, right? And then it gives it to you already. So that is an option that you have. Just remember, if you're solving for the angle, then you can't do it that way. So that gives us 193.444. So B is something 0.44, 193.44, and we are in yards, and it said to round to the nearest yard. Okay, so that would be 193 yards across the lake. So that's how we can do our law of cosines. And then that was it. So those are our story problems. So you want to make sure that you're setting up a picture if there isn't one. You're marking up the diagram if there is one. You're figuring out, do I have a side and an angle across from each other? If you have a side and an angle across from each other, you can use the law of sines. If you do not, then you have to use the law of cosines.